So what we have now is a system of equations with three variables, three equations, three variables. So we're going to solve this by the Gauss-Jordan method, just like before. So in order to use the method, we probably should also understand where it is we're heading. And the goal, if we're using matrix methods here, is to get a matrix that looks like this. Remembering that each, system of equations can be written in matrix form. So this should be apparent by now. We label the coefficients on the left-hand side. We draw the vertical line, and that represents the equals. And then we put the numbers on the right. So remember that this corresponds to x equals a, y equals b, z equals c. And remember that we do this by using the row operations. We can interchange two rows if we want to. We can divide a row by a number if we want to, which means the same as multiplying a row by a number. And we can also combine rows. And it looks like we're going to be mostly combining rows. So I'm going to call these R1, R2, and R3, just like we did before, except it was only 2. So it extends nicely to 3. And I'm going to circle this 1 because that is exactly what we want. The goal is to get these guys to be 0. So the way the Gauss-Jordan method works is you start with where you want your 1, and then you get the rest of the column to be zeros, and then you move from left to right. So with that in mind, so what we're going to do is, again, pretending it's elimination, although I've already decided I'm going to eliminate x from the other two equations. So that's going to require me to take -2 times the first row plus the second row, and that is going to give me a new second row. So -2 times the first row is -2, -8, +4, and then -2 times 0 is 0. And then R2 originally was 2, 3, 1, 15. And when I add those together, I get 0, -5, 5, 15. At the same time, I'm also going to take -3 times the first row and add it to the third row. So I'm using R1 to fix the other rows. Okay. And again, looking at it as elimination of the x variable in each of the equations. So what that's going to give me is a new equation to put in R3. I want an equation there that has a 0 in the first spot. So -3 R1 is -3, -12, +6, and 0 again. R3 originally was 3, -2, -1, 6. And when I add those together, I get 0, -14, 5, and 6. So my new matrix right now is, so I have R1 being 1, 4, -2, 0. I'm not touching that because that has the 1 where I want it. My new R2 is 0, -5, 5, 15. And my new R3 is 0, -14, 5, and 6. And already it's looking pretty good, okay? So we have the first column the way we want it. So now what we do is we move to the second column. And the rule of thumb basically is we need to get the 1 or another number we're comfortable with. We need to get a 1 in that middle column there. And then we want to use that 1 to get the other zeros. Now, one thing I notice is that this row can be divided by -5. And that's really convenient because I want that middle number to be a 1. So I'm just going to write the new matrix with the second row adjusted. So I'm going to have 0, whoops, not -1. I'm dividing by -5. So that's 1, -1, and -3. And I'm still going to keep the last row the same because, again, those are going to change to 0. So I'm going to circle the entries we're going to change to zeros. So what I'd like you to do is pause this video, and I want you to work on the row operations. And then once you unpause it, what you'll see is the result after you do those row operations. So go ahead and pause. Okay, welcome back. And I'm going to write down the matrix you should get after doing the row operations there. That matrix should be 1, 0, 2, 12, 0, 1, -1, -3, and 0, 0, -9, negative 36. So one thing I notice is now the first two columns are done, so this third column needs work. I need this to be a 1, and I notice at this point that I can divide that entire row by negative 9. So there's a tip for you. If there's any point when you're going through this process where you can easily multiply or divide by a number to make things simpler, do so. That's going to save you a lot of work later. So I'm just going to draw an arrow here, and I'm going to, again, keep the first two rows the same. And I'm just going to divide that last row by negative 9, and that's where it's going to get me. And now what we're ready to do, and this is going to be tedious, I know, but we need to get zeros here to finish off the Gauss-Jordan elimination. So again, I'm going to have you pause the video, and I'd like you to do the row reductions. Okay, and then welcome back. So after doing all those row reductions, this is what we have. So the last row should stay the same. We should have 0, 1, 0, 1. We should have 1, 0, 0, 4. So that means that my solution to this system is 4, 1, 4. And if you check that solution in each one of the equations that was given at the beginning, you would notice that that is definitely a solution. So that's probably the worst that a 3-variable system is going to be. Later on, I'm going to show you how to use your calculators to get an easier result, and then we'll see how to use this in application problems. So stay tuned, and thank you so much for watching.